Lesson 4.3, Identifying Special Lines Without Graphing. So system of equations without a solution occurs when the lines are parallel. A system of equations with infinite solutions occurs when the lines are coincident or they overlap one another. Same thing. Any other type of system will provide a single solution. And in order to determine how many solutions a system will have can be accomplished without graphing and without solving the system. This can be done algebraically by comparing the equations and their slopes. You first put the equations into slope-intercept form in order to do this. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. The first step is to put each equation into slope-intercept form. In order to do this, we first look at our equation, and then we isolate the y term on the left side of the equation by moving the x to the right. We can either pick it up and move it, or we can subtract or add it from both sides. If we pick it up and move it, we change sides, so we change signs. Or, as I said, you could add or subtract it, and you get negative 3y is equal to negative 2x plus 12. The next step is to multiply or divide in order to isolate the y and to put the equation into y equals mx plus b form. Since we have negative 3 times y, we're going to divide. We divide everything by negative 3. All terms have to be divided. And we get y is equal to 2/3 x minus 4. We're in y equals mx plus b form. So we're going to put each of these equations into y equals mx plus b form. This one I'm actually going to pick up the x and I'm going to move it. If I move it, I change its sign, so it was positive, now it's negative. Then I divide everything by the coefficient on the y, so I divide everything by 4, and I'm going to get y is equal to negative 3/4 x plus 4. Here I'm going to pick up this negative 3 and move it. So I'm going to get negative 2y is equal to positive 3x plus 10. I'm going to divide everything by negative 2 to get y is equal to negative 3/2 x minus 5. We don't leave this negative in the bottom. We always bring it out front or at top, put it on top. On this one, I'm going to subtract both sides, which will give me negative 5y is equal to negative 6x minus 12. I will divide everything by negative 5. No y, just negative 5. And that will give me y is equal to, I have a negative over a negative, so that's a positive 6/5 x. And I have a negative over a negative, so that's plus 12/5. I leave that as a fraction. My next step is to compare the equations once they're in slope-intercept form. First, I'll check to see if the slopes match. So I'm going to put both of these into slope-intercept form. I'm going to move the x over, and I'm going to have negative 3y is equal to negative 2x minus 2. And then I'm going to divide by negative 3. Divide by negative 3 to give me y is equal to 2/3 x plus 2/3. I'm going to do the same thing with my other equation, which will give me y is equal to negative 4x plus 24. Do my slopes match? No, they do not. That tells me there is one solution, so the system is consistent and dependent. On our next example, I'm going to move the x over, and that'll give me 2y is equal to negative 7x plus 16. I'm going to divide everything by 2. giving me that y is equal to negative 7 halves x plus 8. For my second equation, I'll have negative 6y is equal to 21x plus 24. I'm going to divide everything by negative 6. 21 and 6 both divide by 3, giving me negative 7 halves x minus 4. My slopes match. So now I need to check to see if my y-intercepts match here and here. No, they do not. So the lines are parallel, so there are no solutions. If they had matched, the lines would be coincident and there would be infinite solutions. We're going to check this one next. This is almost in y equals mx plus b format. I just need to move the x out front. Here I'll have y divided by 3 is equal to negative 3x plus 12. I'll multiply the whole thing by 3, giving me y is equal to negative 9x plus 36. My equations match perfectly. The slope and the intercepts match. So these are coincident lines, so there are infinite solutions. So we want to put these equations into slope-intercept form, state how many solutions they are, and then name them as consistent dependent, consistent independent, or inconsistent. So I'm going to pause the video, and I would like you to try these. And then when you're finished, unpause the video and come back and see how you've done. Okay, so I've solved all of these for y. You can see where the arrows lead to show the process for each. And the first one, I get y equals negative 2x plus 9 and y equals 3x minus 16. The slopes do not match. That means that there is one solution and they are consistent independent. I'm going to skip over to the third one. I get y equals 4x minus 2, y equals 4x minus 2. The equations match perfectly. So I have infinite solutions and they are consistent dependent. Now in the middle one, the reason I didn't finish this one is because I wanted to discuss it. I get 12/13 x minus 2/13 and 6 over 6.5 x minus 2 over 6.5. And this is a problem. We don't keep decimals inside of fractions. So I either need to divide 6 by 6.5 and 2 by 6.5 and get an actual decimal answer, in which case I also need to divide 12 by 13 and 2 by 13 to get decimals in order to compare. Or I need to get rid of the 0.5. Now I can get rid of the 0.5 if I multiply the numerator and the denominator by 2. And the reason I want to do that is because I can multiply by 2 over 2, and that's equivalent to multiplying by 1, and 0.5 is a half, so the 2 will take care of that. I need to do the same thing on the 2 over 6.5, and I'm going to get y is equal to 12 over 13x minus 4 over 13. I can now make comparisons here and here. The slopes match, but the intercepts do not, so I have inconsistent. Because the slopes match, my lines are parallel and there are no solutions. So whenever you have fractions and decimals being mixed, you need to either convert everything to just a fraction or everything to just a decimal in order to make your comparisons.